Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep, and I, Rakesh Sir, welcome you all to this next session of electromagnetic theory concepts, and that is the electric field. Having studied the Coulomb's law yesterday, we are now going to move towards the concept of electric field. Come on, let everybody join quickly so that we can begin up the very important discussions of the electric field. All the topics here that we are studying are gradually linked and related to each other. Coulomb's law, with the help of that we'll discuss electric field. Next we'll discuss the concept of electric flux. With the help of that we'll discuss the concept of Gauss law, application of Gauss law, moving towards potential, method of images, all those things to be covered. There's a lot to go, right? Very good evening all. Good evening Achumi, relax, Shalja, very good evening all. Okay, quickly update your friends that the session is live so that they can watch up this concept of electric field here live on the YouTube, on the BYJU'S Exam Prep English YouTube channel. Do not forget to subscribe in case if you aren't subscribed. Okay guys. Okay. Chalo, let's get moving ahead. Let's get started. Just to begin off, this is a brief intro about me. This is your mentor and educator Rakesh. I have secured All India rank 9th in the GATE examination and completed my masters from Indian Institute of Science, Bangalore. And the major area of expertise for me include control systems, signal and system, electromagnetic theory and digital. Other than that, I also deal with the maths and aptitude, and I am also coming live tomorrow. That is Saturday. Just at the same time, as you know, EMT will be on the weekdays, and tomorrow Saturday 9 p.m. I'm going to come live and speak about how to make it possible to score the full in maths and aptitude, and it is possible for engineers, right? For engineers, yes, being engineering domain, it should be easy. It should be, possible for us to grab the 28 out of 28 in maths and aptitude, but you should know how, what should be the strategy, what should be the approach. I am coming live tomorrow at 9 p.m. on the same channel where you are watching this, right? Don't worry, Shalja, just keep on following the classes, step by step understand and learn. And also every Sunday, let's make the Sunday equal to fun day now. Let's make the Sunday as fun day now. So every Sunday, we are now taking up general aptitude practice course. Every Sunday, stay subscribed to the channel, and every Sunday get some dose of practice of the general aptitude, because general aptitude is one such topic where small practice weekly, can make you comfortable in this subject, and also it will be a relaxation to the mind, studying so much of technical and all every time. A Sunday we can have a little bit fun with the practice of the aptitude, right? Also, there is the free GATE starter series that has been started on our app. Yes, you can tune into our app every Wednesday to Saturday at 4 p.m. right? Like tomorrow is Saturday, and tomorrow on this app at 4 p.m. I'm going to take up the concept of how to calculate energy and power within 20 seconds. The fastest tricks to calculate energy and power, and it will be there for all branches, of course, right? For other branches also, the GATE starter series is going on. And now let's get started. Okay, now let's start. Students are very slow and very late in joining today. Why is it so the case? Let us see. Okay, so guys, suppose you have a charge Q placed somewhere in the space. Now understand, we are starting the concept now. Placed somewhere in the space. Also, let this be the charge Q. There is only a single charge placed at a point in the space, and also I now take up another test charge. Okay, let this test charge be QT. Okay, I now take up a test charge QT, which is initially far away from the original charge Q. Let this QT be known as the test charge. And this Q is the source charge. Okay, since it is at a far away distance, right? What is the force experienced by the test charge? The force experience, according to the Coulomb's law that we studied yesterday, the force is given by K Q1, Q2, so Q into QT divided by the R square, where R is the distance between them. And as I am telling, R is initially large. Initially it is at a large distance with respect to the source Q, right? So if R is large, if it is at a considerable distance initially, the force that this test charge will be experiencing is negligible, that is tending to 0, right? It's equal to 0, or let me put it as the force is tending to 0. The force is tending to 0. Okay, sir? The force is tending to 0. Correct. Now, what I will do is, I will now slowly and slowly move the charge QT towards the charge Q. Let us move this charge QT towards the charge Q, right? Let us move it, suppose here. Let us move the charge QT somewhere closer to the Q, and now what will happen, since it is coming closer to Q, it will start experiencing a force. The charge Q will apply some force on the QT. This is what is your updated position of the QT now. So the QT now comes close to Q, and due to which it now experiences a force which is given by K Q QT upon R square. This is the value of R right now. This is the value of the R right now. Okay, this is the value of the R right now. Now, not only at this position will it experience the force only at this position, isn't it? No, na. You can bring this test charge anywhere but close to Q. You can bring this test charge anywhere but close to Q. You can bring this test charge anywhere around Q. You bring the test charge anywhere around Q, it will be experiencing a force that is known as Ft. It will be experiencing a force, that is the force Ft. Isn't it? It will be experiencing a force that is Ft. That is Ft. So this particular force Ft, which is KQQT. Right now I am only taking the magnitude of the force. Later on we will define the direction also, because yesterday we have learned how to define the direction of the force, right? So F, which is KQQT divided by the R square, right? I can say that whenever this test charge is brought somewhere closer to the charge Q, somewhere closer to the original source charge Q, it starts experiencing some force, whereas initially it is far away and hence it is not experiencing any force, or it is experiencing a very negligible force. This shows what? This simply shows that around every charge Q, there is an area, there is a field. Around every charge Q, there is a field wherein if you bring any other charge within that field, that charge will start experiencing electrostatic force. And hence such a field is named as the electric field. Such a field is named as the electric field of the charge Q. There exists a region, एक मैदान जैसा मान लीजिए, एक field, right? A locality you can say, right? If you are not in that locality, if you are not in that region, you don't experience any force. But as you enter this, you start experiencing a force, right? That field, that area, that region, right? We call it as the electric field region. Now, of course, every source charge, let me write down this as source. Every source charge will have some electric field. Right now, what we have written is the force formula. And the force, of course, depends on both the charges. Force depends on the source charge. Also, it depends on the test charge, because force is proportional to the product of the two charges. Let us understand what is the force contribution due to the source charge. What is the contribution due to the original source charge? And to understand the contribution only due to the Q, what we will do it, right? Let's take Qt is equal to 1 coulomb. Let's take Qt is equal to the 1 coulomb. Let's take a unit coulomb charge. The test charge suppose is 1 coulomb, and then what is the force experienced? And then what is the force experienced is kq by r square. And then what is the force experienced is kq by r square. Or simply normalize the force with respect to the test charge. So Ft divided by Qt is equal to kq divided by r square. Ft divided by the Qt is known as the kq by r square, and the force experienced, what is Ft? The force experienced by a test charge divided by the test charge means force experienced per unit charge. The force experienced per unit charge when that charge is brought closer to the charge q is defined as the electric field of the charge q. And this is what we are going to call it as the electric field, which is of course a vector quantity because it is force upon q. Q is charge, which is in coulombs. Charge is a scalar quantity, but electric field ultimately depends on force, so it also has to be a vector quantity. So I will also give you the final vector form, don't worry, I'll also give you the final vector form. But what initially electric field formula is, have a look into this, right? So we have a charge q which is in fixed position. That was my source charge. And I am moving a test charge. And I move a test charge qt around q. Okay. We note that we observed that the test charge is experiencing a force everywhere. Where it is experiencing a force? At here, at this point, anywhere you bring the qt, anywhere you bring it around q, it will experience a force. It will start experience a force. That means it has entered the field. It has entered the electric field of q. It starts experiencing a force everywhere, which displays the existence of a force field, which is just displaying the existence of a force field, and that is known as the electric field, because the force is the electrostatic force here, right? That electric field intensity now is the force per unit charge. As we already defined, it is the force per unit charge experienced by a test charge when the test charge is placed within that electric field. Simply kq by r square of force upon Ft upon Qt, that is the electric field. But because again I am telling electric field depends on F force and it should be a vector quantity, what is that vector? So let us understand by taking another simple diagram here. This is the source charge, right? This is the source charge. Suppose the source is placed at A, right? There is another point P which is known as the point of observation, where I want to calculate the field. Right? What is the electric field at any point? The electric field at any point is given by the force experienced by unit charge divided by the unit charge value, force per unit charge, and that eventually came up to be kq upon r square. Now what is the direction of this force? Everybody can recall from the yesterday's class. What is the direction of the force? The direction given in the Coulomb's law. So to find out that direction, I write down r hat. Where what is r hat? What is the vector r? Where what is that vector r? The vector r, this one, is the vector joining the point A and the point P, joining the source to the point of observation. So vector r here means the vector rp. Vector r here means the vector rp, right? And what is the magnitude of r? Simply I will write it as r or modulus of r. R or modulus of r, that is the length ap. That is the length ap. Distance of the line ap. Distance of the line ap. Is it so? Any disturbance for others in the audio? Okay, sir. Okay. So that R is equal to modulus of R, right? And that is given by KQ by R square into vector unit vector R hat. So what is the unit vector R hat? Vector R divided by R. So if you want, you can also write down in this particular form. So this can now be written as, if the vector R hat is the vector R divided by R. So when you divide by R, you get R cube eventually, and that is the final electric field in the vector form. Final electric field in the vector form. I will write down both the formula. So final electric field in the vector form can be once written as KQ by R square, that is the magnitude of electric field, into the unit vector, right? Or it can be noted as KQ upon R square upon R cube vector R. What is K, guys? Don't forget, K is 1 upon 4 pi epsilon naught for the free space. Right now we are focusing on free space. Later on we move towards the other materials also. Yes, some disturbance is there in the noise. Okay, let me just try to listen. Can be noted as KQ upon R square upon R cube vector R. What is K, guys? Don't forget, K is 1 upon 4 pi epsilon naught for the... Yes, some issues there. Just let me check it out. Just refreshed it. Hopefully the problem is maybe okay or maybe not. You have to just tell me. Yes, some issues. Just let me check it out. Let me confirm whether the audio is now clear. Just refresh it. Hopefully the problem is maybe okay or maybe not. You have to tell me. Yes, guys, quickly update whether the audio for you is now clear or still is there any issue? Still is there any issue with the audio? Fine. Chalo. If now it is fine, then let us move forward and start discussing the things. So that is the formulation for electric field. Final vector form written here also in front of you. I'll again tell you that Q is the source charge whose electric field is being measured, right? This is the charge whose electric field is being measured. This R is the distance of the point at which electric field is being measured, point of observation. We call it as the point of observation, right? And R hat is the unit vector from the source point to the desired point. This is the source point, that is the desired point, right? Electric field. Now what should be the unit of electric field? Very simple, sir. Electric field is force per unit charge, and since it is force per unit charge, force is measured in newtons, charge is measured in coulombs. So one of the unit of electric field is Newton per coulomb. More commonly the unit of electric field is volt per meter. Sir, why? You will understand the volt per meter reason when we go to the electric potential class. So electric field is Newton per coulomb or volts per meter. When you go to the electric field class, you will understand this. Okay? Okay, sir. Okay. Let's move ahead and start discussing. Just a second, guys. Okay, yeah, fine. Okay, so now let's take a simple question to begin off, and before that question, let me tell you some important points about the electric field, and then we take the different type of questions which is expected here, right? Now, electric field, try to understand. Let's go to the previous diagram only where we started the concept. So as I told you, when the test charge is brought closer to Q, sir, where closer to Q? Anywhere. I told you, electric field will exist here. Matlab force can be experienced at this point also, 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 this point, this point. That means everywhere around the charge Q, चारों दिशाओं में, charge Q के चारों दिशाओं में, everywhere around the charge Q, you are going to experience the electrostatic force. So everywhere around the charge Q, you have a force field, you have the electric field, right? And that electric field we just represent by some hypothetical lines. Hypothetical line means they are not some lines which are actually existing, but we draw the line just to represent the electric field. So electric field is represented by hypothetical line which are known as the electric field lines, also known as streamlines or direction lines. So if this is the charge Q, if this is some charge Q, which I call it as the source, electric field is everywhere around the source. That means electric field is radially away from the source. I can say that if there is a source, electric field E is radially away from the source. Is radially away from it. Radially away means away from it in all possible direction. Assuming that this is the center of circle, electric field will be there at every point over the circle circumference. Over the circumference of the circle. That is every point from the center you can reach the circumference. If you want to reach the circumference of circle, you can start from center and take any direction. Same is the story here. So it is radially away. It is radially away from the source charge. Okay. We represent that electric field by the electric field lines just to show that there are some direction, in what direction the electric field is existing. Okay, Chandrasekhar. Right. Now we'll come to second point. This is very important. Let's go to third. Electric field always flows from higher to the lower potential. Sir, why? You might have studied these results, earlier also in physics, that electric field always flows from higher to lower potential. Why? When I take the potential, right now we have not started electric potential, but when we take the concept of electric potential, we are going to talk about this point. That electric field always flows from the higher potential to the lower potential. I will explain you there, right? By the relation that electric field is negative of the gradient of potential. Electric field is the negative of the gradient of potential, is minus del V. To be discussed in the potential class when we start the potential. Electric field does not exist inside the perfect conductor. That also will be proved in the upcoming classes. Right, and electric field never forms a closed loop. Magnetic field lines, when we study magnetostatics, you will see that magnetic field can form closed loop. Now come to the point number 2. Number of field lines per unit area gives the strength of the field at that point, or the important point here is, suppose you measure the field at any of these 2 points at a fixed distance r, right? The field at these 2 points is equal. Okay, the field at these 2 points is equal. Now you measure the field at these 2 points. This will again be equal. But where is the field more? Suppose I tell you there is a point A, and suppose I tell you there is the point B. The field at the point A is EA. The field at the point B is EB. Which of the field will be more? So field is inversely proportional to r square. The field is inversely proportional to r square. It's actually 1 by it. It's a function of 1 by r square. Okay, so more the distance, less will be the electric field. Lesser the distance, higher will be the electric field. So electric field A should be greater than electric field B. Now, if the electric field at A is greater, what about the spacing of the lines? Even if you take a point even much closer, electric field will be even more higher, and look at the spacing of lines. Right? Wherever the electric field is more higher, the spacing of the lines will be less. Right? If we compare A and B also, this spacing, this is a smaller distance, this is a larger distance, right? So when you draw the electric field line diagram, the spacing of the electric fields, the distance between the field lines or the spacing of the lines is inversely proportional to the strength of the field. It is inversely proportional to the strength of the field. That means whenever you have more spacing, that means electric field is less there. Whenever you have less spacing, the electric field is more there. Okay, the electric field is more there. So by the spacing of lines, you can get an idea about the strength of the field. So wherever the electric field strength is 4, electric field strength is more, there the field lines will be close. The spacing will be less. The field lines will be close, means more dense. Electric field lines will look like more dense. Is it okay? Suppose if I want to give you an example. Suppose this is a source. And there are some electric field lines which may be flowing like this. Right? Let me highlight 2 of the points. Suppose there is some point A and suppose there is some point B. At which of the 2 points electric field? I don't know what is the type of source. But I have been given some field lines, at which of the 2 points A and B the electric field is more? Can I say, without applying any formula, without knowing what the source is, just by looking into the field lines, can I say where is the electric field more? Yes, the electric field will be more where the spacing is less, where the density of the lines is more. यहाँ पे बहुत पास चुपका हुआ line है. Here the density is less. The lines are spread far away from each other, right? So wherever the density is more, the spacing is less, there the electric field should be more. So we can clearly say that electric field at the point A should be greater than the electric field of the point B without applying any formula, without the knowledge of source, just by looking into the field diagram. Just by looking into what? Looking into the field diagram. Okay ji, chalo. Now, is it true that electric field lines we always take radially outward? See, it depends on the charge. For our discussion, what is the type of charge we have taken? For our discussion, let's go to the beginning diagram. For our discussion, we have taken the charge, we have taken the source, which is positive. Also, we have taken the test charge, which is also positive. So, if both are positive, sir, means both are like, and like charges will do what? Like charges will repel each other. एक दूसरे को away करेंगे. Like charges will repel each other. That is why the direction of force, right? If this is QT, if this is Q, this Q, because Q2 is same, this Q will be trying to push the QT away. Right? That is why, since our description we have taken the source charge as positive, by default we take it as positive, and the test charge also positive. That is why you see the field lines which are radially away, something like this. Let's have a look into this animation actually. Something like this. So if this is the plus Q charge, the radiation of electric field is away from it, because we have assumed the test charge also positive and like charges repel each other. Due to that concept, this is the direction of electric field lines, which is away, radially away, radially away. ठीक है जी? It is away and radially away. चलो जी, बहुत बढ़िया. It is the radially away. Next. But if you look into this picture on the contrary, right? This is a plus Q, and suppose if I take the source as minus, then QT को plus रखेंगे. Let's take the test charge as a standard positive test charge, right? So if the test charge is QT, which is positive, but the source is negative, sir, then there will be attraction. So this negative charge will be trying to attract the positive charge. Then the electric field lines can be looking radially in, coming towards the source. But if there is a positive charge and QT is by default we take positive, so then there is repulsion, and then the field lines are away, sir. Right? So it is not generally true that we are going to be, the field lines will be radially away. They can be towards the source if source is negative, but it's a normal convention we have taken. This is minus, this is plus. Let me highlight here, right? So normally we have taken the positive source charge and the test charge is also positive. That is why we saw the field lines which are away. Field lines going away from the source, something like this. Okay, something like this. Okay, if this is clear, there is a question for you. There is a simple question to start off. Calculate the electric field intensity at the point 3, 4, 5. Electric field intensity at the point 3, 4, 5 due to a charge of 5 nanocoulomb. Placed at 1, 2, 3 in the free space. Calculate the electric field intensity at the point 3, 4, 5. 3, 4, 5 due to a charge of 5 nanocoulomb placed at 1, 2, 3 in the free space. So there is a point of observation and there is the original. Let's draw this picture here. Right? Due to 5 nanocoulomb charge which is placed at 1, 2, 3. So what is the value of the charge? 5 nanocoulomb. Okay, where it is placed? It is placed at some coordinate 1, 2, 3. Right, in the free space. I want the electric field at 3, 4, 5. See, not necessary to draw the coordinate axis. Randomly I am taking the points. Calculations I'll explain you, right? And suppose this is what is your point of observation, which is kitna? 3, 4, 5. So first of all, quickly let us join them. Okay, just let me join them, the source and the point of observation. Because the source charge is positive. Because the source charge is positive, the field lines will be away from it, as we have just understood. Okay, and this is 5 nanoseconds, 5 nanocoulombs. I'm sorry, this is 5 nanocoulombs. The question here is calculate the electric field at the point of observation at 3, 4, 5. This is the point of observation, and this is what is the source. Okay, so first of all guys, let us try to evaluate what is the vector R. The vector R, as we all know, is the vector from the source to the point of observation. That is the vector AP. And how do you calculate the vector from one point to another? How do you calculate the vector AP? It is the position vector of P minus the position vector of A, as I described you yesterday also, step by step. Position vector of P minus position vector of A, and when you subtract the position vector, so corresponding x to x component, that is 3 minus 1 AX. Y to y component, 4 minus 2 AY. Z to Z, 5 minus 3 AZ. So all of these are 2 common. This is AX plus AY plus AZ. AX plus AY plus AZ. That is what is the vector R. Okay, sir. So here we have the vector R with us. Let me rewrite. Here we have the vector R twice of AX plus AY plus AZ. Vector R is twice the vector of AX plus AY plus AZ. Okay, so what is the amplitude here? What is the magnitude of the vector R? 2 is a constant. Magnitude will be square root of x square plus y square plus z square. Magnitude of a vector formula. So this magnitude is becoming 2 and under root of 3, right? So what will be the R hat? R hat will be the vector R divided by its magnitude. Now let us write down rather than writing R hat here, let us write down the electric field final formula. So sir, what is the electric field final formula? As we know, it is the KQ upon R square R hat, right? KQ upon R square R hat, right? Chalo. Or R hat is the vector R divided by R, so it will become vector R upon R cube. Now let us place the value. What is the K? What is the value of K in the free space? I told you yesterday also. K is 1 upon 4 pi epsilon naught. What is the value of K? It is the 1 upon 4 pi epsilon naught. Putting the value of epsilon naught, K is 9 into 10 raised to the power 9 approximately. Okay. Sure, we'll bring the Lenz's law also in some of the class, Surendra. Right, multiplied by Q. So what is the Q given to you? 5 nanocoulomb. So nano is 10 power minus 9, multiplied by the vector R, which is 2 AX plus AY plus AZ, whole divided by R cube, where R is equal to 2 root 3. So 2 root 3 whole cube. 10 power 9 and minus 9 is getting cancelled. So answer should be electric field is equal to, see, let us do that calculation quickly. 10 power 9 minus 9 is cancelled. 9 5s are 45. Okay, and then you have 2 root 3, and that is cubed up 2.165 or 2.16. Nana, we are finding the magnitude, not the value of AX. I have not put. So the final magnitude that is coming is 2.165 after all cancellations, and then you have AX plus AY plus AZ. What is the unit of electric field? Volts per meter, and this is your final answer in that case. This concludes your answer. 2.165 AX plus AY plus AZ volt per meter is the electric field at the given point in the free space. Right, I hope these calculations are clear to you. I hope this calculations and this explanation is clear to you. Let us go to the next question in that case. Okay, let us go to the next question. understanding a simple question. Okay, there are three charges which are given by, 1 microcoulomb, 2 microcoulomb, 3 microcoulomb. The field due to each charge at the point P in free space is given to you, right? What is the total field? So how do you calculate the total field? What we understood today and what we understood yesterday also, right? Because ultimately electric field is dependent on the force, electrostatic force, which follows what? Which follows the superposition. So what is the total electric field at the point B? So total field, total force, as we were solving yesterday also, is given by the idea of superposition. So total electric field, now how many charges are there? There are 3 charges, right? So total electric field will be given by the E1 plus the E2 plus the E3. It is just the vector sum of this. It's a very simple question. Based on the superposition. So what should be the answer? When you add, AX, when twist, add all of the 3. So AX plus 2AX, 3AX. Final answer I am writing. 2AY plus AY minus AY. So net 2AY. Minus AZ plus 3AZ. So that is 2AZ. So what is your answer? 322. That is the option number C. Newton per coulomb or volt per meter. Option number C. Simple question has simple answer. Simple question here had a simple answer. That's it. Okay, sir. Let's move ahead to the next question then. Please note that it is a MSQ question because the latest pattern of GATE also includes MSQ multiple select question. A point charge is located at origin. At the origin. At the point A, electric field is E1. At the point minus A, electric field is E2. And at a point minus A, the electric field is E3. Which one of the following is or are correct? Which one of the following is or are correct? Right. A point charge is located at the origin. Right. Let's draw the diagram and try to understand in that case. A point charge is located at origin and at the point A, electric field is E1. Okay. So first let us locate that point charge. First let us locate the point charge which is located at the origin. Then you have a point A, which is in the first quadrant where the electric field is E1, right? So there is a point, let me actually, there is the point in the first quadrant, third quadrant and also in the second quadrant. So there is a point A, right, where the electric field is E1. Here the electric field is E1. There is the point minus A, plus A, second quadrant, where the electric field is measured to be E2. There is also a point minus A, where the electric field is measured to be E3. Right. Which of the following is or are correct? MSQ question. That is why one or more than one can be correct. One or more than one can be correct. Right. E1 dot E2 is 0. Modulus of E1 cross E3 is 0. E1 dot E3 is 0. Modulus of E1, modulus of E2, modulus of E3 is equal, are same. What is the correct option? What should be the correct option? Which of the following is or are correct? Shall we check? Okay. So now electric field E1 and electric field, this is A, A. So let us just do a simple calculation here. Let us do a simple calculation. How much is this angle? How much is this angle? This is the How to find the angle? Tan inverse height upon base. If you take it as a right angle triangle, tan inverse height bhi A hai, base bhi A hai. Right, x and y coordinates are same. So tan inverse A upon A, which is tan inverse 1, and that is 45 degree. So guys, if this is 45 degree, this will also be, because tan inverse A upon A, this will also be 45 degree, and total straight angle is 180. 180 mein se when you subtract 45, what you get? 90 degree. What you get? 90 degree. Right? Now, right, looks clear. What you get is 90 degree. So what does this show? What does this show? That E1 and E2 are perpendicular to each other. 90 degree means the electric field E1 is perpendicular to E2, and what is the dot product of the perpendicular vectors? E1 dot E2 is mod E1, mod E2, mod A, mod B cos theta, that is mod A, mod B cos 90 degree, and hence eventually it will be 0. So E1 and E2 are perpendicular to each other, and hence the dot product is 0. So E1 dot E2 is 0. Yes sir, at least this is correct, but it is a MSQ. I can't stop here. Maybe 2 options, maybe 3 options, maybe all 4 are correct. Right? E1 cross E3 or E1 dot E3, only one of them can be 0. So what is the relation between E1 and 3? E1 and E3, they are lying on same line but in opposite direction. They are lying on the same straight line. Electric field is away from the source now. So that is the direction of electric field. They are lying on the same straight line but opposite direction. Right. So what is the conclusion for E1 and E3? E1 and E3 can be called as anti-parallel. The theta, the angle between them is 180 degree, lying on the same line but in opposite direction. Right. So what is E1 cross E3? So E1 cross E3 is given by modulus of E1 modulus of E3 into sine 180 degree n cap, where n cap is the direction of cross product, but here we don't need to find the direction of cross product because sine 180 is coming, which will be 0. The sine 180 is 0. So the cross product between E1 and E3, the cross product between parallel or anti-parallel vectors, it is just 0 only. Right? So this one. B is also correct, E1 cross E3. Anything else? So if they are anti-parallel, they cannot be perpendicular. So C is wrong. C is wrong, no doubt. What about D? Now, what is the magnitude of electric field? Right, what is the magnitude of the electric field? The magnitude of the electric field is KQ by R square, only magnitude. Right, so what is the magnitude of the electric field E1? So KQ upon R. What is the distance? What is the distance? Square root of A square plus A square, root 2A. Okay, distance of A comma A from 0 comma 0, it is the root 2A, so root 2A ka square. And what is the distance even for E2? The source charge is same, so Q is same for all, but the distance is also same, na? Whether it is A comma A or minus A comma A. When you take the distance formula, root x square plus y square, so minus A ka square is A square. So all the 3 distances are same. So this is equal to the modulus of E2. This is also equal to the modulus of E3. So the magnitudes of all are same. And the correct option is also D. So it is a MSQ question where the answer of the MSQ question is A, B, D. Abraham D. Villiers, the great cricketer. The correct answer is A, B, D. All the 3 are correct, sir. All the 3 A, B, D are correct except C. Right? It is a MSQ question where you get full marks only if you select the 3 options correct. Even if you select 1 correct answer, 2 correct. Suppose somebody says, sir, मैंने तो 2 सही किया है. Suppose somebody says, sir, I have done 2 correct, मैंने 2 सही किया, I should get partial mark. You will not get any partial mark. Right? You will either get full marks or 0 marks. Suppose somebody selects C. Suppose somebody says, selects the totally opposite answer C. What will happen? Will he get negative mark? No. He will get still 0 marks. So there is no partial mark, there is no negative mark. In MSQ question, there is no partial mark, there is no negative mark. You will get either full marks or 0. And you will get the full marks if you select all correct options. Ek bhi miss kiya, you don't get anything. You don't get anything. Next question here. 2-point charges Q1 and Q2 are placed at a distance. Yes, this concept is there for ECE also, right? because EC has to ultimately study Maxwell's equation. Maxwell's equation contains Gauss law. One of the Maxwell equation is Gauss law. Gauss law depends on electric flux. Electric flux depends on electric field. So it is totally there in the syllabus of electronics also. 2-point charges Q1 and Q2 are placed at a distance B and A from the origin on the Y and X axis as shown in the figure. The electric field vector at the point P, A, comma, B, that will subtend an angle theta with the X axis. Okay, the electric field vector at the point P will subtend an angle theta with the x-axis. And what is that theta? Yeah, what is the tangent of the theta? The options are asking, right? Electric field at this point. Electric field at this point. पहले इसको हम वो करते हैं. Let me remove this point actually. Okay, so we are interested in the electric field at this point, right, due to the Q1 and Q2. Now just see the simple diagram with me, right? The electric field will be there due to Q1 also. The electric field will be there due to Q1. What is the electric field due to any source? It is radially away from it, especially if it is a positive charge, the electric field is away from it. What is the electric field due to Q2? Is something of this form, right? So let's say this is the electric field E1 due to Q1. This is the electric field E2 which is due to Q2, right? What is the total electric field? The total electric field वो भी देख लिया जाएगा, but first let us write down what is the electric field E1. The electric field E1 should be given by K Q1 divided by, what is the distance? This distance is equal to A. So KQ divided by A square. And what is the direction of this electric field? It is very clear, the direction of this electric field is AX. What is the electric field E2? It is K Q2. Values बाद में रखेंगे. What is this distance? Take that parallel distance. This is equal to B. So K Q2 by B square. And what is the direction of electric field E2? Clearly seen, it is in the upwards direction. That is AY. That is in the positive Y direction. Okay. So net electric field. So there will be some net electric field. Let's say, I don't know, net electric field maybe towards E2 or even depends on which force is heavy, which electric field is more. So let's say this is the net electric field. Let's say this is the total electric field E, and the total electric field E will again be obtained as superposition, that is the vector sum of E1 and E2, right? But E1 is in X direction, E2 is in the Y direction. E1 is in the X direction, E2 is in the Y direction. So we can write down the E1 as EX, we can write down the E2 as EY, because one is in the X direction, one is in the Y direction. Try to recall from the resolution of vector, guys, right? Try to recall from the resolution of vector, what is the X component of any vector? X component of any vector is mod E cos theta. And what is the Y component of any vector? Vertical component of any vector is mod E sin theta. So when you take the ratio for both, EY divided by EX, you get the value of tan theta. You get the value for tan theta. EY upon EX is equal to the tan theta. So from here you can get the tan theta. So EY and EX is the magnitude or magnitude of Y and X component. It is the magnitude of Y and X component. I have named this as EY. I have named this one as EX. So can you guys quickly complete this and give me the answer within a minute? What is tan theta? Magnitude of Y component upon the magnitude of X component. You have to just divide these two and give me the final answer. Just take a minute's time and allow me a minute. I shall be back within few seconds only. Hanji. Right, so I hope you have calculated this. So what should be the value for tan theta here? So the tan of theta will be Ey upon Ex. What is the Ey? That is K Q2 by B is then divided by K Q1 by A. So that becomes A by B, Q2 by Q1. Rest is just the substitution of values. A and B are given to you. A is 2 and B is 1 centimeter. Centimeter automatically will cancel into Q2 by Q1. What should be the value of Q2? Right, what should be the value of Q2? 1 and Q1 is 2 microcoulomb. Right, 1 microcoulomb divided by 2 microcoulomb. Right, so 2 and 2 cancel. 1 and 1. Oh, sorry, this was B square and A square. A square by B square, so 2 centimeter square, 1 centimeter square. 2 square by 2 centimeter got cancelled. Answer is 2. Answer is the 2. Tan theta satisfies the value 2. They can ask the theta also. They've just asked the tan theta, but you can calculate theta also if suppose they were asking the theta. Right? Yes, Sai Charan. So a good logical question involving little bit of the geometry. A good logical question involving a little bit of the geometry, guys. Isn't it? Okay. So with this here, I give you a homework. With this here, I give you a homework. Right? Homework for the day. So yesterday also I gave you a homework whose answer I will reply in the comment box of the yesterday's video. Right, and this is the homework for today. You have to try it again on the equilibrium, right? The electric field intensity of the center. Sorry, indirectly I've told the answer. You please try it out, okay? And again, I will mention you have to reply. You have to mention the answer of this homework in the comment box after the video gets over. Please solve it up. Do mention the answer, and I'll reply tomorrow in the comment box. Right? I'll reply tomorrow in the comment box and. Randomly frame password you get for the PDF. So yes, the PDF of the session will be available in the Telegram. Yesterday's PDF I have shared in the Telegram. Right, I have shared today early morning, very early morning I have shared. So you can again find the Telegram and get the yesterday's PDF. Similarly, today's PDFs of also I will share in the same Telegram, and the password will be field, F-I-E-L-D. Okay, the password will be field. Okay, so you can just open the PDF with this particular password. And now the next class of EMFT will be Monday, that is the Gauss law. The next class of the EMFT will now be on the Monday, and where we are discussing the very important Gauss law, which is one of the Maxwell's equation for static fields, which is also one of the Maxwell's equation. Gauss law we will cover in 2 classes. One will understand Gauss law and all the calculation. Next will be application of Gauss law, where with the application of Gauss law we'll derive the electric field of continuous charge distribution. Today we only saw the point charge, right? Continuous charge distribution like line charge, surface charge, volume charge. Right, continuous charge distribution. What is the electric field due to line charge, surface charge, volume charge? I'll explain you with the help of application of Gauss law. Right, so stay connected on the BYJU'S Exam Prep English YouTube channel. Once again, a quick final reminder for you that tomorrow I am going to come live Saturday at 9 p.m. Tomorrow, Saturday, 9 p.m. I am coming live to discuss up the strategy to secure the best, possibly 28 out of 28. And this is going to be a rank booster for all of you if you really focus on this area of maths and aptitude. And for engineers, it should be achievable. I hope all of you watching the session are engineers. So you can join me live tomorrow at 9 p.m. And then every Sunday, I am introducing a dose for you. Right? Let's make the Sunday fun day by doing practice of general aptitude. Every Sunday, let's make it as a weekly habit. So do not forget to subscribe the BYJU'S Exam Prep English YouTube channel where you're watching this, and Wednesdays to Saturday 4 p.m. on the app. Right, if you don't have the app, if you don't have the BYJU'S app, you can just go to the Google Play Store and download. Right, and every Wednesday to Saturday there is a GATE starter series for all branches. Right, that is running on the app. Okay, so do not forget to subscribe the channel to get all updates and to watch all the sessions regularly. Bye bye. That's it from my side. Thank you. Stay safe and take care of yourself.